Okay, so let's look at this example. So we have 3-point charges located in a line like we see right here. So this is a one-dimensional problem, so it's not as challenging as the next one we'll look at. So our question is asking us, what is the total force exerted by these two charges on a charge Q3? So it's trying to say, what is going to happen to Q3 when there is a charge Q1 and Q2 that is nearby? So let me just write in the charges here so you can see it easier. So Q3 is defined to be 5 nanocoulombs, so times 10 to the negative 9 coulombs of charge. Q1 is 1 nanocoulomb, and charge 2 is negative 3 nanocoulombs. So first of all, we need to see what is going to happen to charge 3. So I'm going to just draw Q3 over here. Here's Q3. And there's basically Q1 is going to, the interaction between Q1 and Q3 is going to result in a force. First, let's look at just Q1 and Q3. So we're just ignoring Q2 at the moment. So Q1 and Q3, they are both positive charges. I know that when they are like charges, they repel. So what's going to happen is Q3 is going to experience a force to the left. So this is the force of charge 1 on 3. So Q1 is going to affect Q3 and it's going to try to push it to the left. Now we're going to look at how Q2 affects Q3. So Q2 is negative, Q3 is positive, so they are unlike charges. We know unlike charges attract. So Q2 is going to try to pull Q3 to the right. So I have F2 on 3. Now there's different things you can do to keep track of signs and stuff when you do these calculations. However, what I like to do for these ones to keep things more organized is just calculate the magnitudes. So what is the magnitude of F1 on 3? What's the magnitude of F2 on 3? Don't worry too much about direction yet. Just find what are the sizes of those two forces. Then afterwards, once we find the actual values, the numbers, and then we'll look back at our picture to determine the direction. So first we're going to calculate what is F1 on 3. So the equation is K Q1 Q3 over the distance between them squared. So K is just 9 times 10 to the 9 Newton meter squared per coulomb squared. And the two charges, we have 5 nanocoulombs. Now we have 1 nanocoulomb. And the distance between them is, what was that? Is given to us to be 2 centimeters apart. So you need to make sure we do convert to meters, so 0.02 meters, and we're going to square that value. So be careful, even though I wrote down 5 nanocoulombs, I know when I'm going to plug this into my calculator, a nano is times 10 to the negative 9. So this is the same as saying 5 times 10 to the negative 9 coulombs. 1 times 10 to the negative 9 coulombs. So we can go ahead and plug that into our calculator, and we end up with a value of 1.125 times 10 to the negative 4 newtons. Okay, I'm just looking at the size. I can also write in here if I want. I know that's going to go left, because I already saw that. It's in my picture. My picture showed me it is going left. Now if you need to just remember, just pause the video and you can try to calculate yourself. I'm going to go ahead and solve for F2 on 3 now. And same formula, K Q2 Q3 over R squared. So we get 9 times 10 to the 9 multiplied by Q2 is 3 nanocoulombs and Q3 is 5 nanocoulombs. And these ones are 4 centimeters apart, so divided by 0.04 meters, or squaring it. So again, I didn't worry about my signs right now, because especially when we get to two-dimensional problems, we know it's just going to go in different, it's like all different directions things are going to travel. So I just plugged in, we get 8.44 times 10 to the negative 5 newtons, and this is to the right. So now I have my two values. I have 1.125 and 8.44, and now what we're going to do is we're going to add those two values. So this is just The sum of the force is just the 1 on 3 plus the force of 2 on 3. So now I can start including signs. So I just define a direction as positive, define a direction as negative. Regardless, what happens is when I subtract those two numbers, I end up with 2.8 times 10 to the negative 5, but the left force was bigger than the right force, so I know it's going to travel left.